Hello everybody. Today we're going to determine what steps are necessary in order to write an equation for the perpendicular bisector of a given line segment. Let's start off with a little bit of a picture here. Your direction is to write an equation for the perpendicular bisector of AB. And if you notice this symbol right here that I'm highlighting, this symbol here means perpendicular. Just going to write perpendicular next to that in pink. Perpendicular. Very good. So an upside down capital T is the symbol for perpendicular. So we see our picture over on the right hand side. We have point A is -7, 1. Point B is 3, 9. And we're going to write the equation of that blue line there with the question mark on it. Okay? So here we go. Write an equation for the perpendicular bisector of segment AB given A is -7, 1 and B is 3, 9. So that's the same picture you just saw. So what two things do I need, or do you always need, in order to write the equation of a line? So I'm hoping everybody knows what those two things are. In order to write the equation of a line, you first off need a slope. Okay, so I'm going to write slope. And then after you have your slope, you're going to need some kind of a point. So over here, I'm going to write point. So you need a slope and you need a point. Alrighty. Most times, any students see a couple of XY coordinate values, they go straight for writing the slope anyway. So let's just pretend that that's what you would be doing anyway. Let's take the point A, which is -7, 1, and also point B, which is 3, 9. And we are going to find the slope of segment AB. Now, before I do that, though, I just want to talk a little bit about this word perpendicular. I'm going to highlight this word perpendicular. The perpendicular lines have slopes that are negative reciprocals of each other. Now, I'm going to come back to that, and I'm going to write that down a little bit as we get going. But perpendicular lines have slopes that are negative reciprocals of each other. So therefore, I am going to find the slope of segment AB, and then I will take the negative reciprocal of that slope to find the slope of the perpendicular bisector of segment AB. So let's keep going on this here. All right, finding the slope. How do you find the slope of a line? Slope has an equation, and I consider slope rise over run. Rise over run, when you rise, you go up and down, and when you run, you go left and right. So up and down movement is a change in the y-axis, and a left-right movement is a change in the x-axis. So it's the change in y over change of x. So I'm going to say little m for slope is equal to, now when I talk about the change in y values, I'm going to subtract y values on my numerator. And when I talk about the change in x values, I'm going to subtract my x values on the denominator. So on the numerator, I have my y values are 1 and 9. See them right here, 1 and 9. Okay. And my x values in the same order that I picked those. And by the way, if you wanted to pick 9 and then 1, you're more than welcome to. You just have to pick the x values in the same order. Okay. I chose the 1 and the 9 to go down first, so I have to choose the -7 to go down first, because -7 and 1 pair with each other. And then I have to choose the 3 to go down second. Again, it wouldn't matter. You can pick the 9 first and then the 1. But then if you do that, then you're going to have to pick the 3 first and then the -7. I'll show you that we get the same answer regardless of what we do in that. Okay, so my slope is, let me see, this is 1 minus 9. This is -7 minus 3. What is 1 minus 9? I'm hoping that you're telling me that's -8. And -7 minus 3, -10. So this gives me a positive, I'll call it 8 over 10 for right this second. But then I'll reduce it. Yeah, I will reduce it while I'm here. 4 over 5. I think you guys have probably reduced it in your head. So you get the same thing if you did this. 9 minus 8. 9 minus, see I said 8 so fast because I have that in my head. And on the bottom here, 3 plus 7. Well, 9 minus 1 is 8. 3 plus 7 is 10. Still, that reduces down to 4/5, right? So these are identical answers regardless of which order you chose to pick your y values first on top. So I'm going to erase this. So I only have one method sitting in there. I don't want the problem to appear to be as more lengthy than it needs to be. Okay, so now that I found the slope of AB, and this is the slope of AB, and I should say segment AB. This is the slope of segment AB. I want to know the perpendicular slope, or the slope that would be perpendicular to segment AB. So what fraction, or just let's say what is the negative reciprocal? I think I'll write that down a little bit later here. What is the negative reciprocal of m equals 4/5? Well, it'll be perpendicular m, which means the perpendicular slope would be the negative reciprocal. So since 4/5 is positive right now, if I negate that, I end up getting a negative, and the reciprocal of 4/5 is going to give me 5/4. So the perpendicular slope I need to work with is 5/4. This is the slope of the perpendicular bisector. Okay, so let's go back up here where we talked about point. Okay, and I'm going to switch my highlighter here for a second. The point I'm going to play with is going to deal with this word bisector right here. Because as you can tell, if I look back at my picture, the -7, 1, which is point A, and point B, which is 3, 9, neither of those 2 points actually fall on the perpendicular bisector itself. So I can't use either of those 2 points in the equation for the perpendicular bisector. I actually need to find a point that lies on the perpendicular bisector. So I'm going to try and find what this point right here is, which is the midpoint of segment AB. So I'm going to come back up here. I'm going to go back to my blue, and I'm going to say find the midpoint, and I'm going to use a capital M, midpoint of segment AB is equal to. Now I'm using a capital M for midpoint because I already used a lowercase m to represent slope. Don't ask me why that happened. Somebody long before me made that rule up there. Anyway, so I want a point that's on the perpendicular bisector of my segment. The midpoint of AB is nothing more than, and this is pretty simple, the average of the x's, comma, average of the y's. I want to find the point that's smack dab in the middle between A and B, because the point that's exactly in the middle of 2 other points is called that midpoint, and that midpoint bisects the segment AB because it creates 2 smaller segments that are equal in length. So let's do this. How do you find an average of 2 things? I'm sure you know it. You add them up and divide by 2. So that's exactly what I'm going to do. I'm going to write capital M, and I'll still write midpoint equals. And now I guess I should have the A and the B written again, but they're right over here. Okay, so I'm looking at the average of the x's. I need to add up my x's and divide by 2. And then I'm going to do the same thing with the y's. I'm going to add up the y's and divide by 2. I don't know why this is doing this on me. Okay, there we go. Add up the y's and divide by 2. Very good. I think what happened was my hand was touching the bottom of my screen, so I had to move it up a little bit. So the x's here are -7 and 3, and the y's are 1 and 9. So my midpoint, -7 plus 3 is -4, and 1 plus 9 is 10. So this is actually a really nice midpoint. No fractions here. They're nice integer values. -2, 5. So this is the midpoint. I'll just write this is the midpoint of segment AB. And you know I don't like any of that, do I? Very good. Okay. Alrighty. So we are going to take this slope and this point, and we are going to use something called point slope form. That doesn't look very nice. Point slope form of a line. And that formula is y minus y1 equals m times x minus x1. Which is pretty easy. If you can just imagine dividing both sides of this formula here by x minus x1, you'd get the formula for slope. Alrighty. So the point I'm going to use is my midpoint, negative 2, 5. So I'm going to put what I need down here. Let's see, y minus blank equals blank x minus blank. And the xy point I'm going to use is this negative 2, 5. And the slope I'm going to use is negative 5 over 4. And these are coming in here, so negative, stop Gina, negative 2, 5, negative 2 for my x, 5 for my y, and a negative 5 over 4 for my slope. And you can clean that up slightly if you want, or, you know, by the time you get to calculus, you can just box that sucker right there and you can say, I'm done, I'm finished. As long as all my stuff is substituted back in, I don't need to do anything else whatsoever. But you could clean it up a little bit. And let's, well, we'll clean it up in just a minute. I know most of you are not comfortable using point slope form of a line. However, you need to get comfortable using it, okay? So I think what I'm going to do over here is just for you to get, you know, the correlation and you understand that it works. I'm going to use y equals mx plus b, which is your favorite. And I'm going to put my perpendicular slope of negative 5 over 4 right in here. I'm going to put my xy coordinate point in, and I'm going to solve for my y-intercept. So my xy coordinate point is negative 2, 5. So I get 5 equals. And what do we have over here? We have negative 5 fourths times negative 2, which is going to give me what? 10 over 4 plus b. I think I'll clean that up and call that 5 over 2 plus b. And now I need to subtract 5 over 2 from both sides of my equation to solve for b. I end up with b equaling 5 over 2. And then I can take that b along with my y equals mx plus b again. I know my, yikes, every once in a while that thing turns on me, I'm not sure why. I know that my slope is negative 5 over 4 x and then plus 5 over 2. And I am just telling you that these two equations are mathematically identical to each other. And I'm going to take the one that's point slope and I'm going to convert it for you so that I can convince you of it. Okay? So I'm right underneath here. I'm just going to write y minus 5 equals, and I'm going to distribute the negative 5 fourths into the parentheses and at the same time eliminate the parentheses. So negative 5 fourths x. Now I have a negative on the 5 fourths and I have a minus sign and then I have a negative on that too. So I have 3 negative signs. They pair off and make positives, so any odd number of negatives is always going to leave me with a negative. And this is going to give me 10 over 4. So this is y minus 5 equals, I'm just going to clean things up. Always take a minute and clean things up if you get a chance. So I reduce the 10 over 4 to the 5 over 2. And now I'm going to add 5 to both sides of my equation. This gives me y equals negative 5 over 4. And I might have a little bit of work to do here. I might have to go to the side and say negative 5 over 2. And I might have to turn this 5 in here into a positive 10 over 2. And I put these together and that will leave me with a positive 5 over 2, which is what I need. Whoops, I lost my x. And then plus 5 over 2. And you can see it certainly did check, doesn't it? Or didn't it? Okay, so there you have it. Go back and make sure everybody's okay here. write the equation, or write an equation for the perpendicular bisector of segment AB, given 2 points. You find the slope, and then you play with the negative reciprocal. So this right here, I'm going to use a yellow highlighter this time. This is what I need to use to write the equation of my line, of my perpendicular bisector. And I played with my point over here, and I got the midpoint, which was negative 2, 5. This is what I needed to use. I put those together in something called point slope form, and I end up getting my final answer. Does that look nice? I hope so. Alrighty. Yeah, I think we're good. How about one more little tiny example, and then we'll call it quits. How's that sound? So this time I won't go so much in detail. I'll just try to go a little bit faster and see if you can follow along with me, okay? Let's see, I have another example. And my other example is going to say, we'll call this example 2. Give me the perpendicular bisector. Come here. Yep, it's not letting me get there for whatever reason. Let me see. Let's call it PQ. If P is the point negative 1, 3, and Q is the point, let me think here, how about 2, negative 9? We'll see how that works. All right, I want perpendicular bisector. So I'm going to want a slope, and slope is going to play with the word perpendicular for me. I wish I could remember what colors I used before, but let's just, yeah, I don't want yellow. I wish I knew, and you know what? It doesn't hurt to just go back and find slope was purple. Woohoo! Okay, so we're going to grab a pink. All right, perpendicular, meaning slope. And we're going to go ahead and find the slope of segment AB first. So slope is rise over run, which is change in the y's over the change in the x's. So that's boom, boom, minus boom, boom, all over boom, boom, minus boom, boom. I'm going to pick my y values on top. These are my y values here, so I'm just going to go start with the 3 and then the negative 9. But because I started with the 3 on the numerator, I must start with the negative 1 on the denominator, and then 2. So cleaning this up just a little bit gives me my slope is 3 plus 9 over negative 1 minus 2. And what is 3 plus 9? I'm hoping you're telling me 12. Negative 1 minus 2 is negative 3. So 12 divided by negative 3 is negative 4. And now I need the perpendicular slope. Remember, perpendicular lines have slopes that are negative reciprocals of each other. So what is the negative reciprocal of negative 4? Well, when we say the negative reciprocal, some people think of that as the opposite reciprocal. So the opposite of negative 4 would be positive 4. And then the reciprocal of 4 means to take 4 and turn it upside down, reciprocate it. 4 is really 4 over 1. So when you reciprocate 4 over 1, you get 1 over 4. Put those two concepts together, and we end up with a positive 1/4. Alrighty, so the perpendicular slope is what I'm going to use right here. Perpendicular slope is positive 1/4, and that's going to go into my formula. Alrighty, and now I'm going to switch, and I have no idea again, so I'm going to scroll back up. Looks like looks like I used green. Okay, well, we'll do it anyway. So this time I'm going to need a bisector, so I'm looking for a midpoint of segment AB. Got to find where that middle is. So the midpoint is capital M, and that is the average of the x's, comma, average of the y's. So I'm simply going to add my x's up, negative 1 plus 2, and divide by 2. I'm going to add my y's up and divide by 2, 3 plus negative 9, divided by 2. Again, that capital M is representing midpoint, not slope. So I have -1 plus 2 is 1 over 2, that's a half. 3 plus a -9 is 3 minus 9, which is -6 divided by 2. So M, which is my midpoint, is 1/2 and then -3. Okay, so here's my green. Here's my word bisector. And because I want a bisector, I want to find the midpoint. And here's my midpoint. Alrighty. So I'm going to do both of those. I'm going to take the slope of 1/4 and a midpoint of 1/2 comma -3. And I'm going to use something called point slope. And that is y minus y1 equals m times x minus x1. Again, this is called point slope form of a line. So this gives me y minus x minus, you substitute everything except the x and the y. As a matter of fact, I'll leave that just like that. So you'll be able to see that I didn't have it in there originally. My perpendicular slope is 1/4. I'm going to put that in here. And the point that I'm going to use is 1/2 comma -3. And I can box this right now. I'm finished. Or I could clean it up if I felt like it and call this y plus 3 equals, and I could leave this the way it is. I could multiply it out and say 1/4 times 1/2 is 1/8. I could indeed subtract 3 from both sides of the equation, and this would yield y equals 1/4 x minus 3 and 1/8. And this is in y-intercept form, slope-intercept form, I'm sorry. Y equals mx plus b. This is y equals mx plus b, which is known as slope-intercept form of a line. All right, and that would be the same thing you would get if you did y equals mx plus b and substituted your point in, solve for b, point in, slope, solve for b, and got done. Okay, here's my final answer here. Oh, Gina, stop that. Very good. Let me highlight my yellow again. Here's my final answer. Or you can put it in the other format. Either way. All good? All good. All right. So now I need to say talent out. Enjoy, everybody.